My name is Professor Alasdair Clark. I'm a Professor of Nanoscale Engineering at the James Watt School of Engineering. So I mostly deal in nanophotonics, which is nano meaning very, very, very small things, and photonics meaning light. So I'm interested in building cool widgets and sensors that do interesting things when we shine light on them, and they exploit the fact that physics gets weird at the nanoscale. So the sensors that we build are around about 1,000 times thinner. The elements in them are around about 1,000 times thinner than the width of a human hair. And when we shrink particular metals down to that size, their optics get a bit weird. So what happens is, instead of gold being a nice yellowy metallic colour, gold takes on structural colour at that stage. So you can engineer any colour into that gold. And what's interesting about that colour is that it's exquisitely sensitive to the medium which is surrounding the gold. So if I have my little gold dots and they look green in air, but I dump them in water, they'll change colour. So what we've tried to do with this idea is make what we're calling, which is a bit of a silly name, I know, but artificial tongues. And what we're trying to do when we dump our liquids that we're doing the sensing on, it's a liquid sensor, is exploit the fact that these little things are going to change colour dependent on the chemicals which are in that sample. There are many industries that are crying out for a tool like this. So what people typically do, and let's stick with whiskey because that's nice and easy to think about, is that they'll have two ways of detecting if their whiskey is any good. They will use centralised lab equipment. It'll give you an amazing chemical breakdown of what's in there, but you're waiting 2 weeks to find out what's in there. Or you have like a human taste panel. Humans are quite unreliable when it comes to taste. So what industry is looking for is, can we have a tool which could sit at the point of need? Can it sit in the whiskey distillery, in the water treatment plant? And can it give us a quick assessment of the quality, for lack of a better word, of that liquid product that we produce? If you're looking at water treatment, we're waiting 2 weeks to find out that 2 weeks ago, there was a problem with the water, but it's already with customers that got there 2 weeks ago. I mean, what use is that? So they need things that are sitting at the point of need. They're simple, they're cheap, and they give you an assessment of the quality of the liquid. And that's what we think we've built with our system.
When I'm out there in the field at different water facilities, everyone's really interested in what the technology is. They want to know what it does, how it works, and they think that it would be great once we've developed it to a point where it could just be a box that sits alone, that it would help solve so many of their problems with being able to identify things. It's been really fun to be able to take this bit of kit out into the actual field, into the real world, and have people working in these facilities wanting to know how it works, and they can see the potential of what it will solve for them. Anyone who produces a product they want to be consistent, this technology is right for them.